Welcome, geometry students. Welcome back, I should say, to part 2 of 3.8. We're talking about perpendicular lines this time. So perpendicular slopes are, what are they? Well, first off, they form a 90-degree angle. So if we have a line here, let's call this line M. Let's be real original, and let's call this one line L. Ooh, super original. So line M and L, they are perpendicular if they meet at 90 degrees. Now, how do their slopes differ? They're not the same. If they're the same, they're parallel. So perpendicular slopes are opposite reciprocals. You can also say negative reciprocals, but that confuses people because they think that always has to be negative, and that's not true. So what's the example? What do I mean by opposite reciprocals? Let's get our green guy here. Y equals, and I'm going to go back to my old friend, negative 3 over 5 x, and let's just make it plus 1. Okay, so there's our first line. So if we're looking at the slope here, I'm going to change the color. I'm sorry if you're using green, but I'm changing the color. I want to make it orange. Okay, so there's our first line. Okay, so if we're looking at the slope, how do we create a perpendicular slope? So perpendicular is this symbol here. We want it to be perpendicular, so how do we change it? So we have y equals, it has to be the opposite. That means since this guy is negative, okay, so he's negative, we want to make this slope positive. Okay, so it needs to be positive. So we're not going to write plus. We're just going to keep no sign. No sign implies positive, okay? And then reciprocal. So because this guy's 3 over 5, we're going to flip him for the reciprocal. What goes on top goes on the bottom. Bottom goes to the top. The numerator goes to the denominator. Denominator goes to the numerator. All right, so we have 5 over 3. So that's a positive 5 over 3. Don't forget your x. Now, if there's no other conditions, it doesn't matter what the y-intercept is. It can even be the same thing. But in this case, let's just avoid that. We'll put minus 8. How about that? So there's a perpendicular line. It's perpendicular slope because it's the opposite, meaning the opposite sign, negative, positive, negative, reciprocal. Another way to express this, the product of perpendicular slopes equals negative 1. This is kind of like a blah, blah kind of thing. Not super important in my opinion, but for some reason your books want you to know this, so whatever, I'll just throw y. So we have negative 3 over 5 times 5 over 3. What happens? We get negative 15 over 15. That equals negative 1. So you see that if you have opposite reciprocals, that they are going to multiply to give you negative 1. A vertical line and a horizontal line are what? Well, if you draw them both on the same coordinate plane, they are going to be perpendicular. Okay, so an example. A vertical line example is x equals, we'll make it 11, ooh, double digits, is perpendicular to a horizontal line, y equals negative 7. So those are perpendicular to each other. Okay, now you're thinking, okay, well, hold on. I thought you said opposite reciprocal slopes. Well, this slope is 0, okay? Or if you want 0 over 1. This is undefined. Undefined can be expressed as 1 divided by 0. So you can see where they're opposite. They're reciprocals there, and you can make it, I guess, a negative 0, but I guess you still follow the same procedure for even vertical and horizontal lines, but it's a special case because it's an undefined slope. So yeah, take that. All right, so then we have L and M here, and we're asked to find, is it perpendicular? Okay, what do we do here? Well, we need to find the slope of these first, so let's start with L. L gets dibs. All right, so L. Now, how do we do that? Well, we need to first label the points. Let's call it x1, y1, x2, y2. Doesn't matter which one you label which. Slope, which is labeled as m, so it's a little confusing, so let me just write out slope, equals, then we have 3 minus a negative 3 in the top, and then 4 minus a negative 5 in the bottom. y2 minus y1, x2 minus x1. We get 6 over 1, we get 6. Okay. Off to a start. Now, let's take an analysis of this. First, if you're trying to find a perpendicular slope, I think it makes sense to leave it as a fraction. It makes it easier to see what the reciprocal is. In this case, a perpendicular slope would be what? It would be negative 1 over 6. Okay, so we're going to do our little maneuver on line M, and we're going to see if we get positive, negative 1 over 6 for that guy. You know what? I just realized, oh, no, we're good. So we get 6. Oh my gosh, how did I make this mistake? No one said anything either. You guys are not looking out for me. So if our slope was 6 over 1, that'd be the case. but I'm sure some of you at home are like, whoa, 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 pump the brakes here. 4 minus a negative 5 is equal to 9. So what are you doing, Mr. West? That's a good question. I did that quickly in my head, and I just did 5 minus 4 for whatever reason. That was a bad move. I agree. So we have 6 over 9. That's 2 over 3. Okay, let's go back. So if we wanted to look for a perpendicular slope, what would it be? Well, it would be negative, because this one's positive, 3 over 2. So negative 3 over 2 slope. Now, let's do line M. Let's make this pink. Pink's been getting no love through these notes. So we're going to go ahead and do line M right here. There's M. I don't know why my pencil's doing that. I think it's the spot on my screen. Anyway, so I can label X1, Y1. I'm just going to label X3, Y3, and then X4, Y4, so you don't get it confused. I know y'all get confused. So what letter is this? Is this M? Whew, that's one ugly M. So we have slope equals our Y4, negative 4, minus Y3, 2, over X4, 0, minus X3, negative 4. Okay, be careful with the negatives like I demonstrated. So we have negative 6 over positive 4. Okay, we have positive, negative 3 over 2. What do you know? That's what we said was going to be perpendicular. This is the opposite reciprocal, so we have perpendicular slopes. Is L perpendicular to M? Yes. Done. As example 3, here's our last one. What is the equation of a line perpendicular to y equals negative 3x minus 5 that contains negative 3, 7? So very similar problem to what we had earlier with the parallel slope. If y'all were here for that, part 1, go ahead and watch it. So we have y equals negative 3x minus 5. First thing we're going to do is we are going to label point and determine perpendicular slope. Okay, let's go and get this all arranged. So our x1, we already know that, it's negative 3. Our y1, I already know that, it's 7. That's the given point. Okay, it has to give you a point. Now, our slope, it's currently negative 3. What I like to do is I always like to put a slope that is not in a fraction into a fraction. Makes it easier to see the rise or the run. Makes it easy to see reciprocals. It just makes it better for everybody. So what is perpendicular to this? If it's negative, it's got to be positive. If it's 3 over 1, it's got to be 1 over 3. So it's a positive 1 over 3. We don't include the plus sign, so just make it 1 over 3. Step 2, what do? We input into point slope form. This is my favorite way to do it. I think it's super easy this way, especially if it doesn't require you to put it in slope-intercept form. Slope-intercept form is overrated. Okay, so then we have our point slope form is y minus y1 equals the slope times x minus x1. So we're just going to input what we know. We're going to say y minus our y1, I changed the color so you see what I'm doing, equals, well, what color was I using? Pink. Equals x, just getting it set up, equals our slope. We said our perpendicular slope is 1 over 3. Go ahead and pause it if you want. Did you pause it? Go ahead and pause it. Pause it. Okay, there we go. Moving on. You're going to have to go back. I bet you can't pause it on that. Anyway, so we have x minus, whoops, wrong color, negative 3. Now we're going to simplify here. We're going to make sure it looks neat. So this doesn't. We need to change that. So we have y minus 7 equals 1/3 x plus 3. And technically we are done. That is a line. It's in point slope form. So we don't need to do anything else. But if it did ask you to convert to slope-intercept form, this is an if, slope-intercept form, it's pretty simple. You just solve for y. Okay, so we solve for y. Too many arrows. Solve for y. Okay, last one. So we have y minus 7 equals 1/3 x plus 3. We're going to distribute first. Boom, boom. Okay, let's go ahead and use, what color? This like blue color? I like that. So we have y minus 7 equals 1/3 x. 1/3 times 3 over 1 equals 3 over 3 equals 1 plus 1. I'm just doing that for those that are struggling to multiply fractions. So then we add 7, add 7. What do we get for our slope-intercept form? We get y equals 1/3 x plus 8. So then we go, we have, these are two, same line, these are equal, and they are both perpendicular to this guy that contains that point. So that's how you do it. Thank you so much for watching part 2. I hope you guys learned a lot, and I will see you next time on West Explains Best. See ya.